Okay, so 10.3 is on functions. Okay, we studied functions yesterday, specifically on plugging in numbers and finding out the value of a function. Okay, what's a function? Okay, it's a type of relation. There were things that were functions, some things that weren't. How do you know when something is a function? We talked about that. Isaiah?
Isn't it if like the first, like the x, if there's two of the same number in the x, like domain
Yep.
thing, is that a function? Or not a non-function?
That's not a function. Yep. If you have a repeat in the x's, that's not a function. Okay? So what we normally say is that there are no repeats. Okay?
So guys, on your notes where it says a function is you want to fill in the rest. Relation in which no two ordered pairs have the same first coordinate.
Okay, so what we're going to do, we're going to look at a different way to visualize a function.
So guys, when we talk about, Mr. Hager talks about that first coordinate, what's another name for that? Who can tell me by raising their hand? What's another name for that first coordinate? Somebody besides Isaiah. Thank you, Isaiah, for volunteering. Kayla.
Domain.
Yeah, the domain, right? And like Isaiah told us earlier, it's also could be the x, right? When we're graphing, the x comes first, then the y. Right? So let's make sure you keep that in mind.
Okay, so one way to graph or look at what a relation looks like is we graph it. Okay, yesterday the last two problems we did, example, I think it was 3a and 3b, we graphed a relation. Okay, and we saw that, I think the one Mr. Roy did, that we had points, none of them lined up vertically. If you have points that don't line up vertically, you're good, that's a function. Okay, the one that I did, I think there were two dots in a row that were in a straight line, up and down. If that happens, it's not a function. Okay, that's what it looks like.
So guys, I'm going to ask you on there, two ways to visualize a function are, what would one way be? Who can tell me by raising their hand? What's one way you can visualize a function? Mr. Hager just talked about it. Somebody besides Caleb. What do you think, Will?
Graph.
Yeah, graph it, right? You can graph it on a coordinate plane. Joe, you know what a coordinate plane is, right?
No.
You know? Who knows what a coordinate plane is? I don't want Joe to be left out in the dark here. Laura. No, what is it? What's it look like? Yeah, and a bunch of lines, right? That's a coordinate plane, Joe. The x, remember that sheet we gave you for homework last night? Those are all coordinate planes. Or coordinate grid. Okay?
Today we're going to look at a different way we can represent a relation, and that's with a mapping diagram. Okay, so we're going to draw a couple circles, we're going to make some arrows, and I'll show you what that looks like. Okay, let's look at this. Okay, so here's a function.
All right, good guys. Before Mr. Hager's going to show you how that mapping diagram works. On your notes, right? You have the two circles, then you have the three lines, right? So, as you're looking at your paper, on the left-hand side, what do you think those numbers are going to be, based on what we talked about yesterday? They're talking about raising their hands. Any numbers we list on the left? Isaiah.
That's going to be x.
Which is also known as the domain, right? So if you want to put domain, maybe in parentheses, put x. So you know those are the x coordinates, that's fine. Domain is D-O-M-A-I-N, domain. Then on the other side, right, will be, what's going to be on the other side? Well, Mr. Hager just kind of gave it away up there on the board, he's sneaky, you know. On the other side would be what? Tyler, what's going to be on the other side? You have the domain, and you have the range, right? Range is also the, what coordinate?
Y.
Yeah, domain is the x, range is the y, good. And guys, this example that Mr. Hager has up here is not on your notes, just watch. Just watch so you can see how this kind of works.
Yeah, it is.
Did I put it on there?
Yeah.
All you do is fill the numbers.
If you want to fill in that diagram, you can. With those numbers, that's fine.
Okay, so let me show you how the mapping diagram works. Basically what you do, okay, Mr. Wright just told you, you put your domain on the left.
And put those numbers right inside the circles.
Same thing with your
Same
range.
Mr. Hager did, yep.
Put your range on the right. Okay, and then what you do is you draw an arrow. Okay, I had a mistake. I had a double-ended arrow. It's just a single-ended arrow. Okay, going from the domain to the value in the range. Okay, so if you look at your ordered pair, 2 goes to what number? Yep, 2 goes to 5. Okay, so draw an arrow from 2 to 5. How about 6? 6 goes to 9. Okay, sometimes these may cross. Okay, if you list them in order, though, the way I did here, they won't. What about -1? Somebody different, tell me where's -1 going to get matched up with?
Guys, raise your hand if you know.
Yeah, Isaiah?
What,
2.
two?
And we've got one more, -3. Okay, where does -3 get matched up? Yeah. 0.
We don't have that.
Yeah, we don't have the four.
That's okay. Okay, so that's the idea of a mapping diagram. Okay, you don't draw an arrow on each end. I had a mistake there, just like it is there. All right. Any question on that mapping diagram?
So guys, would that, what Mr. Hager has listed there, would that be, Justin, what Mr. Hager has listed there on the board, the domain and the range, would that be a function? Sure. Okay, what does sure mean? Yes, how come? Huh?
Because I think it is.
You think it is. So these are Faithford's rules of math. Okay, I didn't know they existed, but very cool. Kayla?
Because none of the domains are the same.
No repeats, that's the rule, right? If we have no repeats, all right, you're good. We don't have any repeats there. Remember, that's Faithford's rule of math. There's no repeats and it's a function.
And with a mapping diagram, the way we're going to see a repeat is you're going to have 2 arrows coming out of the same number. I'm going to show you that.
Yeah.
Okay, when you have multiple arrows coming out of the same number, that means it's used more than once. That's going to be a problem.
Now, think about this, guys. What if we had the opposite? What if we had 2 arrows coming out of the range going into the domain? What do you think about that, Mr. Martin? If we have 2 arrows coming out of the range to a domain number, is that okay?
Yeah.
Huh?
Yeah.
Yeah? Are you confident about that? You kind of give me that look like, yeah, sounds good. Maybe I'll just throw it out there. All right, Austin's back here. He's feeling pretty confident about himself. He's a big man on campus. What do you think? Big man on campus. You think it's a function? Why? Yeah, the domain, only if the domain repeats. If the range repeats, it's okay. Doesn't matter. Okay?
All right. So let's look at this one. Think you guys have this one on your sheet?
Yeah, this is example number 1.
Okay, so the answer here is basically yes or no. And then I'm going to ask you why.
Yeah, I put on there, I put on the below mistake, I put yes or no, circle 1, and then if it's no, why?
Okay. So what do we think? Is this a function? So raise your- Go ahead, yeah. Go ahead. What do you think, Will? Yeah, this is a function. Perfect. And the reason he just said it, the domain doesn't repeat. You do not have 2 arrows coming out of the same number on the left. Okay, so that's a function. How about the one below it?
No.
No, why not?
Because 9 has 2 numbers.
Right, if you were to write out the coordinates here, you've got 9 gets matched up with 3. 9 gets matched up with what other number? -3. And 0 gets matched up with 0. Notice you have a repeat. 9 is repeated. That's why it's not a function. Okay, you don't have to write out the coordinates to do that. You just have to look at the mapping diagram. So no, not a function. There's a repeat in the domain.
So that one Mr. Hager did, that was the no, that was right, that was to the right of the first one. That was to the right of example 1.
Okay, same questions again. Is that a function? Okay, we got it. Just give everyone a second.
Guys, now we're on example 2, like bottom left. Mr. Nermi,
Yeah.
what do you think, my friend? Is that gonna be a function, yes or no?
Yes.
You say yes? How come?
Because it's not. They're not.
There's no repeating?
They're repeating.
Okay, but we have repeats in the range. Is that a problem?
No.
No, right? It's okay if the range repeats. What can't repeat?
We don't.
Domain. Good job, Joe. Trying to trick you. You can't.
Good. So that's a function. Everyone understand what Mr. Roy just said about the repeat in the range? That's okay, but no repeats in the domain in this one? Okay. Okay, how about that one? Is that a function? Emma, what do you think? No, why not? Yep, 16 is repeated, exactly.
So the reason for that, guys, you can just put 16 repeats.
We'll finish up with this one. Okay. How about that one? Is that a function? Yeah. Why is it a function? Yep. No repeats in the domain. Okay, so I'm not sure if the question was really worded to write yes or no. I think I did on the last one, but yes meant function, no meant non-function. All right, so sometimes what they're going to do is they're going to name the function. Okay, sometimes we name it, we just use a letter. For example, this is called function f. Okay, why would we give it a letter? So if we had a bunch of them on the screen at the same time, if I had named the ones on the left, then I could say, look at, function g, look at function h, look at function f, and you know which one I'm talking about. If we don't name them, we don't know which one we're talking about. Okay, so I've named this one f. Okay, we have a -2 in the domain. What does that correspond to in the range? -8.
So hold on, guys, just pay attention for right now. All right?
Okay, how about the 1? What does the 1 correspond to? 4. So what this means is there's a formula. Okay, usually behind every function there's a formula that if you have a value in the domain, somehow you are getting this value in the range. Right now, we haven't known what any of the formulas are. Okay, but does anybody see? If you see the pattern, what you can do to 1 to make it a 4, same thing you can do to 3 to make it a 12. Is there? Yeah, the pattern here is we're timesing by 4. Good. Okay.
So guys, what is that? For the top blank there on the back side, the first bullet, where it says the line, and I just put the line above the, Mr. Hager and I put that line above this to sort of show you guys. So the lines from the domain blank to the number in the range. What's the word that Mr. Hager used in the notes? Spencer. What's the word that Mr. Hager used in the notes? The domain what to the range? Corresponds, right? So for that first blank, the lines from the domain correspond, right, to the number in the range. Correspond means like same thing. It's like it's almost like it's sitting in the same spot, right? See, -2 is the top one on the left, -8, top one on the right, right? They're sitting in the same spot.
Okay, and I want you to think of a function as like a machine. Okay, it's a machine that you put something into it and you get something out of it. So let's think of this as machine F. If you take a 1 and you put it into that machine, okay, what's going to come out of it? A 4. Okay? Somehow this machine is doing something to the number 1 to make it a 4. What's it doing? Isaiah pointed out it's doing some arithmetic. It's multiplying a number by 4. That's what this function does. So that's what you can do when you think of a function. Think it takes a number, it does something to it, and it gives you a new number back, right? And the number that it gives you back is called a value of the function. Right? So the 4 right here, that's an example of a value of the function f. It's one of the 3 values we have up above. Negative 8 is a value of the function, 12 is a value of the function, and 4.
So guys, for that second bullet where it says each number in the range of a function f is called a what? What should we be writing in?
Value of.
Value of a function. Good. Thank you, Candy.
All right. So another way we can say that is when x is negative 2, and scroll back up, when x is negative 2, the value of the function is what number? It's negative 8. Good. Okay, so if you plug negative 2 into your function, the value that you're going to get out is negative 8. So this is the notation that we use to write that. That's the short way of saying when you plug negative 2 into function f,
That's what you get.
you get negative 8.
So we put on the notes too, guys. It's basically asking whatever you get in the domain, what is that arrow matching up to in the range? It's basically what it matches to. Like Mr. Hager said, when you put it in that function machine, right, it computes. What do you get? That was my machine sound. I know it's kind of funny, but I tried. So look at those next two, right? You got function of 1. What would that be? So if Mr. Hager went back up, or if you guys have a sheet too, right? We have 1, right? We have 1 in the domain, right? What does 1 become when it goes to the function? What do you think, Tyler? What does 1 become when it goes to the function? Look at your thing. We're looking at this right here. What does 1 become? 4. Yeah, that's it. All you're doing is looking at and seeing what it becomes, right? Then we have 3. Dominic?
Oh, wait, no, that should be a negative 3.
No, right here.
Oh.
Right over here. Yeah, right over there. When it says F1, right to the almost on the top of the page, guys. That's where that the 2 circles are there, right? So we have f of 1 is going to be 4. Then we have f of 3. Eli, we have f of 3. What do we get?
12.
Good. Perfect. Again, just looking to see where that arrow matches up. And like Isaiah told us, in this particular situation, what is multiplying 4? Are we going to get to that, Mr. Hager? We have to identify tomorrow, right?
I think we'll have some patterns, but we're going to give them the formula.
Yeah.
You don't have to find the formula.
You don't have to identify what's going on.
All right, so everybody see how Mr. Roy was pronouncing that? F of 1 is 4. Okay, that's how you say it. F of 3 is 12. Okay, and that's just a short way of meaning if you plug 3 into function f, you'll get a value of 12. Any questions on that notation? Okay, everyone's all right with that? All right, so let's try this diagram. It says find the indicated value of the function. Somebody tell me, how do you pronounce the first one it's asking for? F of negative 1 is, and now you have to find the value of this function if you plug in negative 1. Okay, raise your hand if you see what the value is going to be. Yep, Brian? 2. Very good. F of negative 1 gives me a value of 2. Okay. Why did I use F? Why not G, or why not a different letter? Why F this time? Look at what was given.
The function.
Yeah, that was the name of this function. They named it F. Yes?
Mr. Hager, can that function be any letter you want?
Any letter you want.
Okay.
Yep. Generally, we might try to stay away from using the letter O. O might look like a 0. But a lot of times they'll use like F G, H, those letters. Okay, how about the next one? F of negative 3. What? 1. Okay? The negative 1 and the negative 3. What kind of values are those? Are those in our domain or our range? Domain. So are they x's or y's?
X's.
Yeah, these are your x's. How about the 2 and the 1? What are those? Y's. What do you get when you put an x and a y together? We talked about this yesterday. What do you get when you put an x and a y together inside parentheses? And it's represented as a point when we graph it. A coordinate, right? So what you really have right here, these are coordinates.
Mr. Hager, we can also call it an ordered pair.
Or an ordered pair. Okay. This function, if you were to draw it, has negative 1 comma 2 as one of its ordered pairs. It also has negative 3 comma 1. Why that's important is because eventually we're going to start graphing these and making pictures. So it's important to understand that this stuff right here really represents coordinates or ordered pairs. Okay? You have x values and y values. Okay, what did they do different on this one? In terms of, look at what's different here. Yeah? Yeah, they changed the letter. This time they're calling it function g. That's fine. Okay? So take a look. When you plug 2 into function g, again, think of it as a machine. What number comes out? Negative 1. How about when you plug negative 4 in? You get 5. Is that a function?
Yeah.
Okay. Yeah. How come it's a function?
X values don't repeat.
Good. There's no repeats in the x's. Are there any repeats in the y's? Yep.
That's fine.
5 repeats, but that's fine. That's fine. All right. So, as Isaiah noticed before and Mr. Roy said, sometimes a function is going to be defined by a formula. Like, take your number and multiply it by 4. Or take your number and double it and subtract 1. Okay? So what we're going to do now is we're going to look at an example that's a formula rather than a mapping diagram.
Hey guys, we have again, we just kind of shrunk this down a little bit. We just put sometimes, sometimes you'll be given an algebraic expression or a rule for the function. So sometimes you're going to do a little bit of math to figure out what the function is. All right?
All right, so now they're giving us some values that are in the domain. Okay, they're
Again,
giving
guys,
us,
on your reference sheet, on your guided notes, this isn't on there. Just watch Mr. Hager and I do it one time. Then I think you should be able to do it.
so they give you some values. These are the values that are going to be put into the function machine. Okay? Sometimes we call them inputs. Okay? We use domain, we use range, we use x, we use y. Sometimes we use input and output. Input is the number you start with. Output is the answer you get. Okay? Here's the formula. Can anybody explain what that formula is basically saying to do? Yeah, you add 2. So for example, if you wanted to know f of, pick a number, 5, what would you do? The formula says to add 2 to it. Okay? So yeah, you'd get 7. That would be the answer. Okay, so this is what we just said. For each number in the domain, the value of the function, or the value you get in the range, you just add 2. That's all you're doing. Any question why this formula means add 2? That's all it is, just add 2. Okay, so let's try a couple. F of 5, I think we just did that one, but let's do it again. Okay, so to find f of 5, what do you have to do with the 5? Take the 5 and,
Add 2.
yep, you're going to plug it in right there. So you plug it in, you get 5 plus 2. 5 plus 2 gives me 7. Okay. How would we find f of 12? What do you have to do with the 12?
Add 2 and 14.
Yep, but what do you have to, how do you know to add 2? What do you have to do with the 12 first? Yeah, you got to put it in.
So do we have to do like the 5 plus 2 equals 7, or do we just do the answer?
Sometimes the arithmetic's going to be a little more complicated than just adding 2. So yeah, I'll have you show that step. Okay, so you show what you're finding. You're finding the value of the function at 5, how you found it, and then your final answer. So what's the value of the function at 12? 14. Very good. Okay, any questions on that? Okay, so here's one I want you guys to try. Okay, it gives you a function. This time they're using f as its name. F of x equals 4x squared minus 1. So now you got to remember a little about PEMDAS. You got to remember what do you do first. Okay? But I want you to try to find those 3 values.
You guys, you have this on your notes.
Okay, so what are we going to have to do each time?
Multiply.
Plug in. Yep, exactly. You're going to take every one of these numbers one at a time, and you're going to plug them in for x. Let's start with 3, f of 3. Hey, Joe, can you tell me how am I going to find f of 3? Explain what I need to write down to do it. So we got that part. We got f of 3. So now what's going to go on the right side for my calculation? Anyone help him out? How do we figure out f of 3? What would you, if somebody asked you, I don't get how to do it. What do you tell them you do?
3 minus 1.
They won't understand though. Explain how'd you get, I'm not sure why. Right now I've got nothing here. So where'd 3 minus 1 come from?
You can take the domain of 3 and minus it.
Okay, what do we have to do before we start doing any arithmetic? Because I still don't understand where 3 minus 1 is coming from. All I see is a 3, and then I see a formula, 4x squared minus 1.
You make 4 squared minus 1.
What did you do? What is that?
I just had parentheses.
But how did you get that? What did you do?
I replaced the x with 3.
Exactly. Replace the x with the number in the domain. Okay? So that's step 1. Now let's be careful with the arithmetic. PEMDAS. There's nothing in parentheses. It's just a 3. What's the e in PEMDAS?
Exponent.
Exponents. Okay, so we always do exponents next. What do I get when I do my exponent? 9. Now we have 4 times 9 minus 1. Do we do 9 minus 1 or 4 times 9?
4 times. I mean 4 times 9.
Yeah, basic arithmetic. Remember, multiplication is always done before subtraction. So what's 4 times 9? 36. Minus 1 is going to give me 35. Good. Okay, so the value of this function, if you plug in 3 for the x, you're going to get a value of 35 for y. Okay. How about finding the value of the function at 1? What's my first step?
Plug in the one where the x is.
Plug in the one where the x is. Okay, who can tell me what to do next? Yep.
Exponents.
Do your exponent. What do you get?
You get 1.
You get 1. Okay. What's 4 times 1?
4.
4, and then 4 take away 1? 3. So this one says if you plug in 1 for x, the value of your function is 3. It's kind of like having the coordinate 1, comma, 3. And let's do the last one. Joe, can you tell me what to do now with the negative 2? Same thing we did on the last 2.
You put 4 down.
So what are you going to do with that negative 2? No one help him out? What's the first thing we got to do, Brian? Plug it in. Change the x to whatever value you want to find. Okay, now you got to be careful here because you're squaring a negative. What kind of number do you get when you square a negative? Positive, right? It's negative 2 times negative 2, which is how much?
4.
4. So we've got 4 times 4, which is not 8, that's 4 plus 4.
16.
16. And what's 16 minus 1? 15, good job. Okay, any question on that one? Seems okay with that? All right, so this one, I want you guys to try it on your own. Okay? They give you 3 values in the domain, negative 3, 0, and 3. They want you to find the range. How are you going to find the range? What are you going to do with all 3 of these numbers one at a time? Plug them in for what? For x. Okay, plug them in for x one at a time and try the arithmetic. Okay, so give that one a shot on your own. What's the first thing I have to do if I want to find the value at negative 3? Yeah.
You gotta replace the, okay, yeah, so it's first you have to find
Okay, guys, I can't hear. Hold on. Yeah, Austin, go ahead.
Put your domain down. Yeah, I mean, you replace the x. Here.
Replace x with whatever value in the domain. So we'll do one at a time. First thing I'm going to do is just write down what I am finding. So this way, on the test, okay, when I'm grading it, I know what you're finding. Okay, what value are we plugging in? Negative 3. Okay, what's negative 3 squared?
No.
Negative 3 times negative 3.
It's 9.
9.
Positive.
Did I oh, negative 3 on there, 9.
Okay, what's negative 3 times 9?
Negative 27.
Negative 27. Now be careful, what's negative 27 plus 6?
Negative 21.
Negative 21. Okay, what value should we do next? How about William, what value you want to do next? 0. Okay, Isaiah, tell me how to do 0.
Yeah, I'm great.
How do I do 0? How do I plug in 0?
That's Eli.
Oh, I'm sorry, you got yeah. So we got negative 3.
0. Exponents to
6. Yep. Okay, guys, I need everybody's attention up here. Everyone's attention up here, okay? And then what else do we have to add? Plus
6.
plus 6. Plus 6. What's 0 squared?
0.
What's 0 times negative 3?
0.
And then 0 plus 6.
0.
0 plus 6?
Yep, 0.
Okay. We get 6. Okay, what's the last value we need to find? One more value. Justin, what's our last value? 3. Okay, so we're going to plug in 3. Kate, how do I do that? How do I plug in 3?
I was looking -3 in parentheses 3,
Plus 6. Okay, Marcus, what do I do next?
Do, 3 squared.
3 squared, which is, Isaiah, how much is that?
3 squared is 9.
What's -3 times 9?
Negative 27.
-27
I thought it was already right in the negative, so.
plus 6?
Negative 21.
-21. What do you notice about the values in the range?
The 2 were the same.
Yeah, there's 2 that are the same. Is that a function?
Yeah.
That's fine. Okay? Okay, so what I'm going to do, okay, for your homework tonight, okay, on page 384, it's 1 to 10, 15 to 18, 23 to 26, and 31 all.